Let's take a look at some hydrocarbons and compare alkanes to alkenes to alkynes. Okay, so an alkane is a saturated hydrocarbon, meaning all of the carbon-to-carbon bonds are single bonds. Now these are line angle drawings. So we have 1, 2, 3, 4, 5 carbons, saturated alkene or alkane. So this is pentane. Okay, pentane. 5 carbon chain, saturated hydrocarbon, all single bonds. Now, when a double bond appears, okay, now we're looking at an unsaturated, where we have all single bonds, we have saturation. This is unsaturated. Again, it's 5 carbons, so it would be pentane, but once we have the double bond present, then it becomes pentene. So the ane becomes ene. Okay, so pentene. Now we have to give the location of the double bond. So we have carbon 1, 2, 3, 4, 5. If we number left to right, if we go right to left, 1, 2, 3, 4, 5 would be the third carbon, would be where the double bond originates. We want to go with the lower, so we'll go 1, 2, so 2 hyphen pentene, meaning 5 carbons, double bond at the second carbon. And now we have an alkyne. Okay, an alkyne. So again, 1, 2, 3, 4, 5 carbons. So it's pentane is the root, but once we see that triple bond, instead of pentane or pentene, it becomes pentyne. We have the YNE suffix for triple bond designation. And again, we need to tell the location of the triple bond. So carbon 1, 2, 3, 4, 5, or number 1, 2, 3, 4, 5. We want to give the lower value. So 2 pentyne. Now if we want to change these, we can write the formula CH3, CH2, 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 and CH3 for the alkane. And see here in the pentene, the 2 pentene, at this second carbon, we now have a double bond there. So we only have 1 hydrogen present rather than 2. We only have 1 here. Again, we have 1 hydrogen instead of 2. See that double bond? There's the 2 pentene. See, as we add these multiple bonds, we're reducing the number of hydrogens on those carbons involved in the multiple bonds. And then with the 2 pentyne, we've got CH3, got the C to C triple bonds. So there are no hydrogens there. See, 1, 2, 3, 4 bonds. We have CH2 and CH3.